We are live. All right. So we're going to talk about chapter 17, which is language of hypothesis testing. Okay. So let me give you an example. So you and a friend bet on a coin flip. Okay? Because you're gamblers and crazy. Okay? Heads, you win. The coin comes up tail, 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 tail. Which sucks for you, right? Okay? So I want to ask two questions. What is the probability of tail, 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 tail? And is this evidence of your friend, or should I say your former friend, cheating? Okay, now let's think about this for a minute before we get too far. 5 flips of a coin. Is that a very big sample size? Probably not. Okay? So if you're going to base a friendship on 5 coin flips, you're probably in trouble already. Plus, besides the fact that you're betting on a coin flip in the first place. Okay? So this is a very small sample size. Okay? So that's the first thing to notice. No, it's pretty small. But let's assume that this is what happens. Okay? So, Drew, what's the probability that you come up with a tail on the first flip?
50%.
50% or 1/2, right? Carson, second flip.
1/2.
Also 1/2. Third flip, Emma?
1/2.
1/2. Buck? 1/2. And Colton?
1/2.
1/2. You guys are pretty good at this. Okay, so that would be 1 out of 32, which is, what would be that as a percent? I think, check my math, but I think it's 0.031. Correct?
Yeah.
Are you using the phone?
I am.
Shame on you. Okay? Can't use it on Thursday. Good thing we didn't have a quiz today, or you'd be in trouble.
I do have a calculator.
Okay, you do have a calculator. Good. All right. So now, what would we assume our significance level is if I don't tell you?
0.05.
0.05. Okay, so that's the probability that you're wrong. So if you're wrong 5% of the right, if you're wrong 5% of the time, how often are you right?
95.
95%. So if this happens just 3% of the time, would you say that there is enough evidence of cheating? This only happens 3% of the time.
Yeah.
Yeah, there would be evidence, right? Yeah, but I guess, right? But what?
It's possible.
So it is possible. If you flip a coin 5 times, 3 times out of 100 that you flip it 5 times, you're going to get 5 tails in a row, right? Okay. So, is there evidence of cheating? Yes, but what?
There's like not a lot of evidence because it's very unlikely that it would happen because it happens 3% of the time. Is that what you're asking?
No, well,
The sample size is too small.
sample size is very small, but sample size is small. Okay? The probability that you get 5 tails in a row, it's not very likely, but it does happen 3% of the time. And if we assume that if it's less than 5%, it's unlikely, yeah, it's unlikely. Gosh, that's a very small sample size. Okay? So you might not want to lose your friendship over it. Maybe you will. If you're betting, $1,000 on a flip, you're out $5,000, right? Okay? And you need to go to Gamblers Anonymous if that's the case.
So how did you come to the conclusion that yes, there was evidence of cheating?
How did I come to the conclusion? Because I said that anything less than 5% of the time is unusual. And that is unusual. So if it's unusual, then I'm going to say yes, there's cheating. Okay? So anytime, I didn't record this to my other class, but if the p-value is low, oh, I haven't introduced, you know what, I'll save that phrase for later. Because I got to introduce some other stuff before I can finish that. But there's going to be a little rhyming thing there that's not politically correct, but it'll help you remember that. We'll save that for later. Okay? All right. So here's what I would like to do is I want you to remember this I'm going to give you an outline for the rest of class on hypothesis tests. But let me also mention it also can be used for hypothesis tests are 2 different ways to do basically the same thing. Okay? So you're going to want to probably memorize I'm going to give you 7 steps. You're going to probably want to memorize these, and then hopefully every day I'm going to say, okay, what's the first step? What's the second step? Based on your answers to these 7 steps will help you to figure out which hypothesis test that we can use. Okay? Now the homework that's due on Thursday is only going to be the first 3 steps primarily. No, actually, I think we'll go through all 7 one time. Okay? But most of it's going to be dealing with the first 3 steps. Okay? All right. So step number 1, list all the important numbers. Okay? Number 2, is the data categorical or quantitative? Okay? So I know we learned that, I think it was the first week of class. Yesterday in my class, they still got that question wrong. So it's time to make sure that we can get that right. Let's see if you guys do better. Okay? We're getting kind of low on the board. We'll go over here for step number 3. Now I'm going to put step 3 over here. Sorry. It's still on the video though. Except for the videos all of a sudden out of focus. I don't know why. There we go. Thank you. Step number 3 is find the null and the alternative hypothesis. Okay, now I'm going to need to explain to you what is a null hypothesis. Null hypothesis. Okay, it's represented as H sub 0. Okay, you can all, oh, I guess it's backwards over there on the screen. No, can't see it. So you can read backwards. Find the null and the alternative hypothesis. You got it, Jose?
Sorry, will you say it one more time, number 3?
Number 3, find the null and the alternative hypothesis. Okay? All right, so now let's talk about what is the null hypothesis. The null hypothesis is a mathematical statement that means no change, no difference, or in this case, a fair coin. Okay? Some things to remember about it. It is always, and I know you like that word, always about the population. Okay? Always. Part B, it always has an equal sign in it. Okay? Maybe I should change that one to almost always. There's actually, we'll do one in case where it doesn't, but almost always has an equal sign. For the homework, you can say it always has an equal sign. Yes?
That's always about population.
Population of it, right? And part C, it's often not stated directly. Okay? Now let's talk about the alternative hypothesis. Alternative hypothesis. Okay? So it depends on your book, and I can't remember what this book does. I'm going to use either one. You can see H sub 1 or H sub A. Okay? I will use both here. There's no real difference. Just whatever I'm in the mood on that problem. Alternative hypothesis can be written either way. Okay? The alternative hypothesis is a statement we are trying to prove. Okay? I will also mention it's always about the population. Part B, it never has an equal sign. And part C, it's often directly stated. Okay? So the null is often, that's not stated. The alternative usually is stated in the problem. Okay? All right, so that's what you need to know about the alternative hypothesis. Okay? Step number 4 is to pick the test statistic. Okay? So, now this is going to be based on the answer to question number 2. Is your data categorical or quantitative? Okay? So if the answer is quantitative, okay, you have 2 options for the test. Okay? And I'm going to give you, so realize this is for the rest of class, so I'm going to introduce some stuff that you're not going to learn for a few chapters. Okay? If the answer is quantitative, then it could be one sample mean, sigma is known. Okay? That's going to be using the equation z equals x bar minus mu over sigma over the square root of that. Just went barely off there, but you know that's long enough. Okay? 2, it could be one sample mean, sigma unknown. Okay? Now, we haven't learned this yet, and we won't learn it today. We will learn it probably on Thursday. Okay? So the difference between 1 and 2 is sigma is known versus sigma is unknown. In the case that sigma is unknown, it's going to be a t-test. It's going to be x bar minus mu over s over the square root of it. We'll learn more about that on Thursday. Okay? All right, so those two are the equations that we will use if it's quantitative. Now, the question is if it's categorical. Okay? There's also going to be two different tests here. Trying to decide if I should, you know what, I'm going to give you the equations here, even though we're not going to learn it for a week or two. Okay? It could be a one sample proportion. Okay? And that equation is also going to be a z-test, but it's going to be a different equation. It's an equation you haven't seen yet, but we will learn it in the future. It's going to be p hat minus p over the square root of pq divided by n. Okay? And the other option is it's going to be an independence test. Okay? The independence test is going to be a chi-square test. It looks like a script x. It's the Greek letter chi. Okay? And the equation is the sum of the observed minus the expected squared all over the expected. Okay? So, I may introduce to you another test. I haven't decided yet. But these are for sure these four we're going to do. I might throw another one in there. Yes?
What's in the square root for the b equation?
P times Q divided by N.
B times
P times Q divided by N.
PQ over N.
PQ over N. We'll explain that one in a few chapters. Okay?
And then number
So I'm really introducing to you a lot more than you need to know at this point. But what I am going to say is, hopefully this is going to get super repetitive. We're going to get a problem, and I'm going to say, let's go through all of these these 7 steps. So I'm hoping that if I give you how to do it all today, this is still going to be hard, but it won't be as hard. Hopefully some of you will learn it. Okay, so we're only to step number 4. Now I will mention, based on yesterday, they had problems with steps 1, 2, and 3, but 4 is usually the hardest step. And if you get step 4 wrong, ain't no way you're going to get this problem right. Okay? 4 is kind of the critical step. Okay? Now let's move on to step number 5. Step number 5 is find p-value. Okay? Now, step number 6. Oh, and I should mention here, it could be one tail, or it could be 2 tail. Okay? We'll talk about how to do that later on. Okay? Step number 6 is decide to reject or do not reject. Okay? Now, a lot of you think the opposite of reject means accept. Okay, we've already got one A word. What's the previous A word that we had? Average, right? I'm going to have another swear word besides average. Word we never accept. Okay, that's a new swear word in our class. Okay, sorry for swearing. Okay, you reject or you do not reject, maybe I should finish this statement, the null hypothesis. Okay? And so now I started to introduce to you a phrase here. Okay, so I'm going to introduce this phrase. If the p-value is low, okay, reject the null, or some people like to say ho because it rhymes better. Okay? I know that's not politically correct, but it is memorable. And apparently they teach it up in the math stat lab. Does anybody go to the stat lab?
I go to the math lab.
The math lab,
There's
yeah.
not, there's like, it's not a good stats resource.
It's not, yeah, they moved it out of the low C center, I found out. Okay? Question, Emma.
What does it mean, like, what does low mean? Between,
So
like,
we're going to
0 and
compare our
1?
p-value to our alpha like we did the first time.
Oh, okay, okay.
Okay? So if your p-value is low, reject null. Okay? And step number 7, you guys are going to like step number 7. Step number 7 says write the conclusion in English, not statistician. Okay? Which means, when I say that, do not use the words reject, null, or hypothesis. Okay? Going back to here, what it would mean is you want to answer the question, is your friend cheating? Yes, there's evidence your friend's cheating. No, there's not evidence your friend is cheating. That's what I'd like you to say. Okay, essentially. Because before today, how many of you have ever heard of the word null hypothesis? Only one person, 2, okay? So most of you don't speak that way, okay? So don't start speaking it just because we're in statistics class. We need to make this understandable to non-statisticians out there, okay? All right, so here's what I would like to do. Most of chapter 17 is going to focus on the first 3 steps, okay? So we're doing pretty good on time. We might do a problem, but what I'd like to do at the beginning here is focus on these first 3 steps, okay? And make sure that you've got these down. This is what most of the homework is on. We will, if we have time, we'll do a problem. I think we will have time. That's going to deal with this equation here. So the nice thing is, if you get a problem that has enough information to solve, we're going to use this equation. Okay? All right. So I almost wonder if I should give you guys some more homework. Because I was looking over your homework and I didn't think there were enough good problems. There's some good problems for the first 3 steps, but for step number 4, actually 4 through 7, it's not very good. I think I will, okay? I'm going to give you some more problems. And then hopefully that will help you guys ace this. What most of your homework is going to be like, okay? So, let's see here. Let's do an example. Okay, let's do an example. Now, by the way, these first examples, there's not going to be enough information to solve. I just want to go through the first 3 steps of these. Pharmaceutical company has a new antibiotic for children. Okay. Other antibiotics show 2% of children get a headache as a side effect is FDA wants to know if the new antibiotic is more than 2%. Okay? Find the null and the alternative hypothesis. Okay? Okay? So there's not enough information to actually solve this. Basically, what I really want you to do is I want you to do the first 3 steps. Okay? And this is where I'm going to get super picky. Okay? So, pharmaceutical company has a new antibiotic for children. Other antibiotics show 2% of children get a headache as a side effect. 2% sounds like that might be useful information, right? Okay? So, what equals 2% or 0.02?
Children get headaches.
Okay? Children get headaches. So now, here's where I'm going to be really picky. I want you to pick the right letter. In fact, maybe, as we're doing this, let's also ask, is your data quantitative or categorical at this point? Should we vote? Maria shook her head. She doesn't want to vote. Let's vote. Who says it's quantitative? 1, 2, 3, 4. Who says it's 5? Who says it's categorical? Nobody? Who doesn't know? Okay, well, that was the honest answer. But none of you got that answer right. You were like 2%. That's got to be quantitative, right?
Yeah.
Because that's a number. But we use numbers with categories too. Okay? So let's think about this. If this is a categorical data, which I just told you, why would it be categorical?
Not a lot of quantitative data.
Well, why would you thought it was quantitative? So that wasn't a very good clue. Yes?
Like you look at what you're measuring.
Okay. Here's a good clue, 2%. Now, I'm not going to say that percent is always categorical because there are times where it will not be categorical. Okay? But no, I won't say that. Many times, when you see a percent, that's a good clue that it might be categorical. Okay? So the categories are headache or no headache. You got a headache, you didn't get a headache. Okay? All right. So, since it's categorical data, what letter do I use? To represent categorical data. P, why P?
Because it's proportional.
Because it's a proportion. You got the right answer there. Good job. Okay? We're going to use P because it's a proportion. And proportion is what we use for categorical data. Okay? FDA wants to know if more than 2%. Okay, so there's not a lot of information here. The other information that I would like to know, what's my alpha?
Is it 0.02?
0.02?
0.05?
0.05?
You said if it doesn't say, just assume it's 0.5.
I said if it doesn't say, we assume that our alpha is 0.05. Doesn't say, right? Okay? So we'll assume that it's 0.05 because it doesn't say. So what are some other common alphas that we could be? Did I tell you? I think I told you that before, didn't I? Buck remembers.
What?
What are some other common alphas?
I have no idea.
0.1,
0.1 or
0.01.
0.01. Okay? Think of this as the probability you're willing to be wrong. You're wrong 5% of the time, 10% of the time, or 1% of the time. Okay? So if it doesn't say, we're going to assume 5%. There were a couple of questions. Emma, did you have one?
No.
No?
You answered my question.
I answered your question. Okay? If it doesn't say, it's 0.05. Okay? All right. So we've listed all the important numbers, of which there weren't very many in this problem. Is the data quantitative or categorical? Question.
Okay, so I remember. So if it did specify the alpha, what would that look like in the problem?
Use an alpha of 0.10.
That's what it says.
It'll say that.
Oh, okay. All right. Cool.
Okay? All right. Find your null and your alternative hypothesis. So let's review here. Okay? Null hypothesis is a mathematical statement that means no change, no difference, or fair coin. It's always about the population. It almost always has an equal. I'm going to put the equal there right off the bat. Okay? And it's often not stated directly in the problem. Okay? So as we look at this, what would be a mathematical statement that means no change, no difference? Fair coin doesn't apply, so I'll ignore that. No change, no difference. And it's about the population.
Would it be the children that don't take the medication? Because they're not having any change?
What are we measuring?
Would it be 2% of children get headaches?
We're measuring the percent of children who get headaches, okay? So what's a mathematical statement that refers to children who get headaches?
We like 2% of children take.
2% of children. Okay? And some of you are going to stop there and you're going to be like, I don't know what letter to put, so I'm going to stop there, and you'll only get half credit.
Letter before the equal sign, is that what you're talking about?
What's the letter before the equal sign?
P.
Is it P? Who thinks it's P? One? Jose doesn't even think it's P. Who thinks it's not P?
Oh man, I was trying to be a Q.
Emma, you were right.
Oh,
Come on, stick to your guns. Okay, we just said P equals 0.02. That's about your population, right? What else did you think it would have been? Okay? So you can see these steps are hard, aren't they? We're just getting started. Hopefully, by the next test, you'll be like, oh, this is easy. Okay?
Will those letters always match each other then?
They should.
They should, but is there some tests where they'll be different?
Well, we're going to do some other ones that will get even trickier than this. Hope this was the easy problem. Okay? All right, so the alternative hypothesis, okay? H1 or HA, I picked H1. Statement we are trying to prove. What is the statement we are trying to prove?
If the new antibiotic is more than 2%.
The FDA wants to know if the new antibiotic is more than 2. How do I write that as a mathematical statement?
We should put greater than or equal to 0.02.
Okay, remember, it never has an equal sign.
Or greater than
So something is greater than
0.02.
0.02. What's the something?
P.
P, are you sure, Jose?
Yes.
You really sure?
Yep.
Okay, good, thank you. Stick to your guns. Okay? All right, so does that make sense? Most of your homework is going to be doing just this very thing, just the first 3, well, really step 3, but I want you to do the first 3 steps just to get used to it, okay? Does that make sense? Yes.
Why is P used for all?
Why is P used for all of them? That's a really good question.
It's because it's about the population.
Number 1, it's about the population. We use P when it's about the population. What's another reason?
Isn't it because
Categorical.
It's categorical. Those are the 2 reasons.
Okay.
It's categorical and it's about the population. Okay? All right, should we do another one?
Yes.
Should we do one without a P this time?
How would you, like, if we just went over just step 7, how would you say this in like English? Like what are,
Write the conclusion.
Like
Okay,
the
so what
results.
does the FDA want to know?
Whether the new antibiotic.
Does the new antibiotic have more than 2%? So there's two possible conclusions you would have. What would be the two conclusions?
No, yes.
New antibiotic what? Does not have more than 2% headaches, or
It does.
it does have more than 2% headaches. That's exactly what I want you to write. Okay? All right, so let's do another one. Okay. Now, all right, here we go. The blue book value for a 3-year-old Chevy Corvette is $37,500. Grant wants to know if the price is different in Miami. Okay? Find the null and the alternative hypothesis. But before we do that, let's answer the first two questions. Drew, what do you think are some important, what's an important number we ought to know about?
$37,500.
$37,500, okay. That's a good start. What equals that?
A 3-year-old Chevy.
3-year-old Chevy, but that's not a letter. What letter do I want to pick? Probably P. Who agrees with them that it's P? Who disagrees? Why do you disagree?
Because you said we were doing it without.
So who are doing one without P? I already gave you that. It's not P. Why is it not P? Okay, is this categorical data? No, this is quantitative data, right? These 1 and 2 kind of go together. You could do 2 first if you want. It's quantitative data. When I'm using quantitative data, what letter do I use?
T?
P?
No, T.
T. Okay, you're skipping to step number 4, which is kind of helpful, but not T is not what I'm looking for. Mu, why mu?
Population.
Because it's the population mean. We think the population mean is $37,500 according to the Chevy Blue Book, right? Okay. Are there any other numbers?
3 years old.
3 years old, is that helpful to the problem? No, except for the fact that I gotta make sure I'm not doing a 20-year-old Chevy Corvette, right? Okay. Any other numbers?
The alpha.
The alpha. What's the alpha in this case?
What's your flow?
0.05. Why?
Doesn't say.
Because I didn't tell you. Okay. All right. So we've got all our numbers. There's not enough to do this problem. So we've listed the numbers. We said it's quantitative data. What is our null and our alternative hypothesis? Rachel, it must be your turn. Can't hear you.
One of them was 37.
Ah, that would be a good guess. Is one of them the 37,500? That would be a good guess. Okay, so let's review the null hypothesis. It's a statement that means there's no change, no difference. It's always about the population. It almost always has an equal sign, and it's often not directly stated.
So mu equals 37,500.
Mu, do you agree with that, Rachel? Are you sure?
Yeah.
Didn't sound very convincing.
Yeah.
Yes. Okay, that was better. That was more convincing. Okay? All right, the alternative hypothesis. Who did I pick on? I think I picked on everybody. Buck, it must be your turn again. Okay. What is the statement? The alternative is the statement we are trying to prove. What's the statement we are trying to prove? What does Grant want to know?
The price is different. And
Is different. What does different mean?
It could be lower or higher.
Could be lower or higher. So how can I represent that as a mathematical statement if I don't know if it's lower or higher?
Plus or minus.
Can you do like 37,500 greater than mu, lower than
Do you want to use the greater than and the less than sign? Is there an easier way to write that?
It probably is, yeah.
It probably is. What do you think, Buck? How could you be writing greater than or less than sign without writing a greater than or less than sign?
More than that.
Come on, you gotta be creative there. I know you're a Dallas Cowboy fan, but you know, still.
I'm not sure.
That's almost as bad as a Laker fan. You wanna take it over? What do you got?
Not that. Well, my guess,
Cowboys and Lakers gotta stick together.
my guess would have been 37,500 is less than mu, which is less than, wait, hold on.
You guys are making this way too complicated.
Isn't
I
it
realized.
plus or minus?
Plus or minus. It's big here.
Save B. Clifton. I don't know. Oh my God.
It's just it's a mathematical symbol that none of us know.
It's a mathematical symbol that none of you have ever seen before.
Oh,
Come on. Okay, not equal to. We don't know. We don't know. We just know it's not equal to that. Could be more, it could be less. Now, one other thing that I didn't mention, okay, step number 5 asks if this is one tail or two tail. Maybe I should have mentioned this on the last one. But on this one, okay, this is useful for step 5. It's not probably that useful for the homework tonight. But the idea here is if it's quantitative, we're dealing with a mean. Which one of these equations am I probably going to pick out of the 4 that I got?
The T,
Either the t or the z, right? We didn't say anything about the standard deviation, okay? Let's assume it's a z for sake of argument. We know that the z looks like a bell curve, right? Okay? We don't know whether, if this is the mean, we don't know whether it's higher or lower, okay? So this is what we're going to call a two-tailed test, okay? It could be an either tail, okay? The previous one, we only wanted to know if it was more than 2%. So it was going to be only a right tail test, greater than, right? Because we thought this was 2%. Okay? All right, so you don't need that for the homework today, but you will need it later on. Okay? So this is what we're going to call a two-tailed test. So we're going to use the not equal sign here. Okay? Can't believe that was so hard.
So in a two-tailed test, you always do just not equal to.
Yes, in a two-tailed test, you always use not equal to. Okay? Should we do one more? Let's do one more, and then we're going to actually do a real problem. We'll try to hurry through this so that we can do an actual problem. Okay? All right. You guys are going to be good at this one, though, I hope. Okay? All right. The standard deviation of a 64-ounce bottle of detergent is known to be 0.23 ounces. Company purchases new machine and wants to know if there is less variation. Okay? Find the null and the alternative hypothesis. Carson, what are some of the important numbers we should know?
0.23 ounces is the standard deviation.
0.23 ounces is the standard deviation, and what letter do I use for standard deviation?
I have no idea what the name is.
You don't know what the name is?
No,
Sigma?
Can you air draw it for me?
it looks like a sideways 6. That's how I draw it.
Sideways 6? That works. That's called the Greek letter sigma. Who agrees with Carson? 1, 2, 3, 4. Who disagrees? Nobody? Must be right then. Okay? Sideways 6, Greek letter sigma. Why did you pick sigma and not S?
Because it tells you the standard deviation of a 64-ounce bottle of detergent.
Yeah,
So
but
now-
S is standard deviation too, right? Why is it sigma and not S? Clifton?
Because the populations.
Because it has to do with the population. Is that what you're going to say, Maria? Yes. Because it's always about the population, and S is what?
Sample.
Sample standard deviation. Okay? All right. Any other numbers we should know, Buck?
It's 64 ounce.
64 ounces. Is that useful? No, other than we just want to make sure we don't use a 32-ounce bottle or something, right? Okay, that's more descriptive. Okay? Any other numbers, Maria?
Yeah.
What? The alpha. What's the alpha?
0.05.
0.05 because
Doesn't say.
I didn't tell you. Okay? All right, Emma. All you do. So we listed the numbers. Is the data categorical or quantitative?
It's quantitative.
Are you sure?
Yeah.
Yeah, I'm not very confident though. How confident are you?
Not very.
Not very. You were supposed to say I'm 95% confident. Okay? Yes, it's quantitative. Why is it quantitative?
I don't know if this is right, but I've just been remembering it and like it's not comparing. Well, it is comparing. I don't know.
Anybody know? Jose?
It's quantitative because it's not categorical.
Quantitative because it's not categorical. Okay. Could we change this into a categorical problem? How would we change it into a categorical problem? Okay.
If it was like comparing two different kinds of detergent.
Either it's full or it's not full. Would that be categorical?
Yeah.
Okay. All right. So we could change it into categorical if we said it was full or not full, and 15% of bottles were not full. Okay. All right. So this is quantitative. All right. It's time for the null and the alternative hypothesis. Colton, it must be your turn. He's like, I wish there were more people in this class so I didn't get picked again.
Just do the equal sign.
Gotta have an equal sign in it.
U.
Mu. Is that what we're measuring is mu? Quantitative. This one's a little bit of a trick question. I don't have any of those over there at the other sigma, do I? It's for my math 2040 class, but, so it's not mu. What are we talking about?
The standard deviation.
Talking about standard deviation, right? So which did I put here?
Sigma.
Sigma
0.23.
0.23. Okay, we're using sigma because sigma deals with the population, right? And we're measuring, so here's one thing I will say. This one was a little bit of a trick question. This is not one of the ones you're going to learn, but I did want you to be able to pull out the null and the alternative hypothesis, even though this isn't a test we're going to do in this class. But who's going to sign up for my Math 2040 class next semester? You're like, I've had enough of you. I don't want to see you again. Okay? All right. The alternative would be what, Drew? What are we trying to prove?
You want to prove that there is less variation.
Less variation. Okay? How do I write that?
If the amount in there is less than the standard, or less than one standard deviation. Is that correct?
Not quite. Okay. Carson?
It'd just be less than 0.23.
0.23. Whatever number I pick there, I'm just going to keep going with. So what's less than 0.23?
I don't know the right letter.
Carson does.
Sigma.
Sigma. Okay, you see why? Whatever you picked here, you're going to pick here again. Okay? Everything's going to be the same except for this middle symbol here. Okay? All right, now would you like to rush through one more? And we're going to do all 7 steps in 5 minutes. Here's what I'm going to say. We're going to use this equation. Okay? Because I know that I gave you at least one of these problems on here, so I want to do one really quickly. Okay? See if I can have 1 minute. Let's say that oh shoot, I'm going to do one here. Hopefully they're there. Let's say that you think people are speeding in a school zone. The local police, school zone 25 miles per hour. Local police tell you that the standard deviation is 7 miles per hour. You measure 16 cars and find mean speed is 29 miles per hour. Is this evidence of speeding? Okay?
What's the mean speed you wrote? Example.
29. This number here? Okay. We've only got a couple minutes left, so I'm gonna do this super fast, okay? You are gonna have at least one problem like this on here. The speed limit is 25 miles per hour. That's what the population is supposed to be going, right? Okay? Local police tell you the standard deviation is 7 miles per hour. We're gonna assume that the police know what that is, so that's gonna be 7 miles per hour, okay? You measure 16 cars, your N is going to be 16. You find the mean speed is 29 miles per hour. That's your sample of those 16 cars. That's going to be X bar. Okay? Don't have an alpha. That's going to be 0.05. Okay? All right. So I've listed all the important numbers. Is my data categorical or quantitative? Clearly quantitative. Find the null and the alternative hypothesis. What's the speed they're supposed to be going? Supposed to be going 25 miles per hour. You think people are speeding. What does that mean?
They're going
You think they're going faster than 25 miles per hour. It was a one or two-tailed test.
So one.
It's going to be a one-tailed test, okay? So we've done the first 3 steps. We're going to step number 4 now. I told you that all your homework is going to be doing with this. This is the equation you're going to use. We're going to use z equals 29 minus 25 over 7 over the square root of 16. What does that equal? I need to figure that out really quickly.
4 divided by 7, 4.
Right.
So
Okay, I'm going to do that super fast. 4 divided by parentheses 7 divided by, oh, I didn't do the parentheses. This is why I like Excel. 4 square root equals 7 divided by the square root of 16 equals this divided by that. So I got 2.28. My z-score is 2.28. You guys know how to find the p-value, right? It's going to be here, here 1 minus this of 2.28. Okay, I get a value of 0.011 p-value. Now, if this was a two-tailed test, is it a two-tailed test?
No.
No, so I'm going to take it as is. If it was a two-tailed test, I would double that. Okay? So that's why we care if it's a one-tailed. One-tailed test because I only care about greater than. Okay? 0.011. Do I reject the null or do I not reject the null? Is my p-value lower than my alpha? Yes, so
You
therefore
reject.
I reject the null. 0.011 is less than 0.05. 1% is less than 5%. Okay? So I'm going to reject the null. Write the conclusion in English. Is there evidence of speeding? Yes, there is evidence of speeding in the school zone. Okay? We think they're going closer to 29 than they are to 25. Are they going to get a ticket for 29? Depends on which county you're in and whether they want to make money on it. Okay? All right, so homework is due chapter 17 on Thursday. This will be the equation that you'll use. I think there's only one problem that probably can use this, but this is it. This is all 7 steps. You're going to focus mostly on this, okay? I'm probably going to give you some more, maybe over the weekend, I'll give you some more homework to do these because I don't think there's enough in chapter 7. I tried to look for some more and I didn't find any, okay? See you all on Thursday.